Obtain a block of wood and record its letter and number. Carefully measure the length, width, and height of the block to the nearest 1/100th of a centimeter. The block we've chosen is Z2. Next, you want to obtain the mass of the same block of wood. When doing so, you may see some uncertainty in the last digit of the scale as the reading changes up or down in the hundredths place. The objective is to just record the best value. Here we will record 92.4771 grams. Next, using the formula for density, determine the density of your block of wood, which is Z2 for this instance. Since the formula for density equals mass over volume, we can take the mass of our block and divide by the volume of our block, which is length times width times height, and derive the density for it. Take note that density is a characteristic property of a substance and can often be used for identification purposes. Samples of a given kind of wood have similar densities. These densities differ from the densities of other kinds of wood, and your objective is to compare densities of several types of wood and try to identify an unknown sample of wood. It will be your responsibility to calculate the density of block Z2. The instructors here are calculating the density of block Z3 and Z5. The density for block Z3 is 0.512 grams per centimeters cubed. Z5 is 0.518 grams per centimeters cubed. We've also measured the unknown block A to calculate its density. Don't put that on there. And see if it could potentially be within our series. The density for unknown A was 0.519 grams per centimeters cubed.
Obtain a cylindrical can from the side shelf. Measure and record in centimeters the inside height and diameter of the can. Then calculate the volume of the can using the formula pi r squared h, which is pi times the radius squared times the height. Remember that pi equals 3.142. Next, fill the can with water to the same height that you measured. Carefully measure the volume of the water in the can by pouring it into the 100 milliliter graduated cylinder. Note any sources of error that may occur as you pour the liquid into the container, such as spilling. Remember to interpolate between the lines when measuring the volume inside the graduated cylinder, and to read the bottom of the meniscus. Remember the volumes that you measured, add them together, and that should equal the volume in the can. Remember to consider any error that happens if you spill or anything else that may have happened. Here, we're estimating that the volume inside the cylinder is approximately 300.01 milliliters. When you consider the air, that's where the 0.01 may come from. We estimate that the volume that was measured out is approximately 300.01 milliliters. These volumes should correspond to one another. If they don't, think about why that could be. Weigh a clean, dry 10 milliliter graduated cylinder. The mass of this is 42.6678 grams. Then carefully add between 4 and 5 milliliters of one of the liquids, A, B, C, or D. Read the liquid level at the bottom of the meniscus and be sure to interpolate between the two smallest markings.
.99 milliliters.
Be sure that the outside of the cylinder is dry, and then re-weigh the cylinder with its contents. After adding the liquid, the mass has increased to 47.5469 grams. The difference between the two masses is the mass of the liquid. You can then calculate the density of this liquid by dividing the mass by the volume. So the units for this measurement will be grams per milliliter. Then you can compare the value that you obtained for the density with the values in your manual to identify the unknown liquid that you used in the experiment. Place about 5 milliliters of water in your 10 milliliter graduated cylinder. Measure the volume to the nearest 0.1 milliliter. Take a clean, dry beaker, choose an irregular solid, and place 1 spoonful of it into the beaker. In this case, we are using copper. Then weigh the beaker with the solid. This mass is 68.3335 grams. Carefully transfer the solid into the cylinder until you've displaced 2 or 3 milliliters of water. The difference in the values of the two liquid levels is equal to the volume of water displaced and also the volume of the solid. Weigh the beaker again with any leftover solid. Now the mass of the beaker and the solid is 53.3133 grams. The difference in the two masses is equal to the mass of the solid that you added to the graduated cylinder. You can then use those values to calculate the density of your material using the mass divided by the volume. The units for that will be grams per milliliter. You can then use that density value and compare it with the density given in the appendix for copper.